Hello everyone, we are going to continue solving quadratic equations. This time we will be using square roots. So the thing with square roots is that you can only use it if you do not have the bx term. So as you can see here, I have ax squared equals c. This is the typical format you will see for these type of quadratic equations. So just be sure that there is no bx term in order for you to use this square root method. So before we go into actually factoring, let's review square roots. So one thing that you need to remember is that when we are taking the square root of a positive real number, you will have two answers, okay? You will have a positive answer and a negative answer. So there's going to be two numbers that are going to be your solutions here. All right, so let's go into the square root of 25. Now I'm looking for two numbers that if I multiply them, they will give me 25. But it's not just any two numbers. They have to be the same number. So for 25, I know that 5 times 5 is 25. So my square root of 25 is 5. But like the notes say, you will have one positive and you will have another one as negative. So the square root of 25 is either 5 or negative 5. Okay, so square root of 18, same thing. But the thing with 18 is that there are no two numbers that are the exact same that will give me 18. However, I can simplify this further. So I know that 18 can be broken down into 2 times 9. Okay, I can't break 2 further down because that would just give me 1 times 2. But I can break down 9 into 3 times 3. So because I broke down 9, I'm going to scratch it off. I no longer need it. So whenever we are thinking square root, we are looking for pairs of numbers that are the exact same number. So for this case, I have a pair of 3s. So I can take that out of my square root. Okay. Then anything that is left over goes underneath the square root symbol. Okay, so that's where my 2 stays. But we said that we need a positive and a negative. So I'm just going to put a plus or minus sign here in front of the 3 square roots of 2. So that's what we do for square roots. Now let's look into factoring. So here's my first example. I have 2x squared equals 98. But before I can start taking any square roots, I need to remove that 2 that is my coefficient on the left side. And so because it is 2 times x squared, I do the opposite, which is to divide by 2. When I divide by 2, on the left side, 2 divided by 2 becomes a 1, but it's an invisible 1, so I don't have to bring it down. So I have x squared equals 98 divided by 2 gives me 49. So now I need to remove that exponent, that squared. And the way we remove it is by doing the opposite, which is taking the square root. What you do to one side, you have to do to the other. So the square root and the squared cancel each other off, and I'm left with x is equal to the square root of 49. Well, 49 is a perfect square, and it gives me a positive 7 and a negative 7. So x equals 7, and x equals negative 7. Those are my answers. Those are my solutions. Wow, this is so easy. I know it is. It's super easy, okay? So here is example 2. Gosh, I knew you guys were going to say that. Okay, so here, before I can do anything to that negative 3, I have a constant here of 12. Now that 12 can be combined with this negative 48 if I move it to the other side doing the opposite operation. So instead of adding 12, I'm going to do the opposite, which means to subtract 12. So I'll do that from both sides because it's a constant. Okay, when I do that, that becomes a 0, and I'm left with negative 3x squared on the left. The right side becomes negative 60. Now my next step is going to be what we did in example number 1. I get to divide by negative 3. When I divide by negative 3, I get my invisible 1. So I have x squared equals 20. I'm going to bring this over here to the left side because I'm running out of room. So I have x squared equals 20. At this point, I can take the square root of both x squared and 20. I know the square root and squared cancel, so I have x is equal to, there's no two numbers that are the exact same that will multiply to give me 20. However, I can break down 20. 20 is just 4 times 5. And then I can break down 4 further into 2 times 2. So I can scratch 4 off. I see that I have a pair of 2's. So x is going to be equal to 2. And the 5 didn't get circled, so it stays underneath the square root symbol. I have a positive and I have a negative. You can also write it as x equals 2 square roots of 5 and x equals negative 2 square roots of 5. Now for the last example, this one looks a little bit different. We don't have a coefficient or a constant outside of the parentheses here. So we need to tackle that exponent first. So I know that the way I can remove a squared is to do square root. So I'm going to do square root, take the square root of both sides. And I know that the square root and the squared will cancel off. So when I do that, what's left over? The only thing that's going to be left over is everything inside of the parentheses, which is x plus 7 is equal to the square root of 81. 81 is a perfect square. The square root of 81 is 9. So then at this point, I have x plus 7 equals a positive and a negative 9. Okay, well, what do I do here, miss? I don't know what to do. This is kind of weird. Well, we just set up two equations at this point. Okay, so I'm going to have x plus 7 equals a positive 9 and x plus 7 equals a negative 9. So I subtract 7 on both sides. When I do that, I get x equals 2. That's my first solution. When I subtract 7 on this side, on the second equation, I get x equals negative 16. So these are my two solutions. And that's how you solve a quadratic equation using square roots.